Okay, so what we're doing is we're looking up here at what was due today. So, oh, this is biology, my bad. Periodic families. Okay, so that's due today. So if you haven't got it in online, make sure you do today as soon as possible. Again, I will start deducting points for late work and things like that. Again, there's going to be an attendance policy goes into effect for online people. So you need to make sure that you're paying attention to it. They haven't released what it's going to be yet, but just be looking for it. Okay. Also, we will be having a quiz this week, Thursday, on the families. You need to know what they are and about various information over the periodic table. All right. So pretty much it's going to be about the periodic table and the information that you can get from it. Okay. All right. Then also for those of y'all in here, you need to take out whatever you take your notes on because we're going to be talking about some things today. If you edit your notes that we have, that's fine. You can do it that way, whatever you need to do. All right. All right. But this right here is what we're going to be talking about. This sheet. And basically, all you were doing is just taking information from one place and putting it in on this. And this will be your main study tool. Okay, coming up. There'll probably be, if we get to it today, which I'll let you know, some of the basics on atomic structure and things like that, that will be on there. Okay, so make sure that you are aware of what's going on. All right, so let's look at this your periodic table that where you had to identify all the families and everything. All right. Jasmine, you just turned in a blank sheet, right?
Yeah.
Okay. Okay. Some of the people that have been coming to the online study sessions said that that's really helpful. Again, you guys are welcome to be there for those. Okay. So um, we do them like for first period, it'll be today at 1:45. Let me go ahead and make an announcement about that. And then for it'll be today at 1:45 and then Thursday at 1:45. So it's just the days that we actually meet in class, and it's mainly geared towards the online people, but you guys too. You're welcome to be there. Which I realize you'd have to get home pretty quick, but um, you're always welcome to be there. When is your quiz? Thursday. All right, so looking at this right here, we're just going to go through, and I realized some of it was probably hard to see and everything. It's a little bit easier to see when it's online because it shows up in colors, but unfortunately, we don't have that luxury. Okay, so just looking at this and everything, pay attention up here, and we will get it done. All right, can you all see this? I realize the wires are in the way. Okay, so just looking at this right here, I'm going to ask you all a couple of these that we can just write them in. All right. So A right there, Emily. What is A?
I have no idea.
That is the atomic mass. Okay. Atomic mass. All right. B, Will, what is B?
The symbol.
Yeah, it's the element symbol. Okay. It would not hurt to go start reviewing those kinds of things if everybody ended up doing fairly well. What is C, Connor? C. Right. Yeah, atomic number. What is D, Wells Fargo? Yeah, element name. Element name. Okay, good. Jasmine, what went in box E? E, as in egg.
No.
Transition elements. Okay. So everything basically from family 3 to family 12 is a transition element. Okay. That's why on these periodic tables, and you can't see it on that one, but if you look in your book, that they're designated like 1A, 2A, then it skips. And these right here, they have the B's by them. Okay. But they are the transition elements. And the reason why is because these have all kinds of mixed properties that are similar. They all have multiple, some of the elements individually have multiple oxidation states, which is something we'll talk about later. Okay, but they're not exactly like these families right here, where, basically the whole family has the same properties. With this one, it's all of these together that share similarities. Okay. All right. What is F, Tony? What goes in that box?
Is it the metal?
No. Okay. Basically, what that arrow is pointing to, it means everything to the left of that line right there is a metal. But you are correct in that, you know, basically they've kind of went away from talking about these elements that are the semi-metals or the metalloids as that. They've kind of went into they're more metal-like or more non-metal-like. Okay. Samara, what went into G?
I don't know.
Well, if this one's a metal, what do you think these over here are? Non-metals. Okay. All right. H. Maddie. What'd you get? You didn't get it? Okay, I'm sorry, I didn't hear you. All right. Yeah, well,
Lanthanide.
yeah. Lanthanide series. Okay. Josh, what'd you get for I? Actinide system. Or not system, but series. Okay. So basically, these two right here, they kind of are extracted out. Okay. And they start with these two elements. So that's why they call them that according to their name. Okay. So they call this entire one the lanthanide series. And this one's the whole, all of it is the actinide series. So uranium, is it part of the actinide system or the lanthanide?
Lanthanide.
Actinide, good. All right. Okay, so in the next part, I think that's all the letters, right?
What about J?
Where's J?
It's not on the paper, but it's like
It's vertical along with the periodic table to the left.
all the way near lithium sodium.
Oh, over here.
Yeah, there's that one.
Yeah. What do you call those?
Like the rows,
Yeah,
like the families with the columns are
they're the rows. So families are vertical or columns. So this is talking about all of these. What are these called?
Wait.
Huh?
Wait.
I don't know.
Well,
Guys, y'all had a periodic table I gave you that had exactly the same words on it.
Period.
Periods. Thank you. These are called periods. This is a box, not J periods, but periods. I misspelled that word. Because why are they called periods
Is it periodic?
in nature? Yes. And what does it mean to be periodic in nature?
Repeating
It's repeating.
or reoccurring?
Okay. So what you'll see is that, you know, all of this family right here, which we're getting ready to talk about, with the exception of hydrogen, because it's not a metal, it's a non-metal. Okay. They're highly active metals. Okay. So every time when you move from, when you go across and you get back to this one, okay, then it repeats. Their oxidation number is the same. Their electron configurations are basically the same, in which basically that is what gives it all the properties, but we'll talk about that later. Okay, so that's all the boxes, right? Okay, so next thing you were to do was to basically go through and you were to put a color in of the different groups, okay, or families, and describe or name them what by their names. So we've already talked about the transition element, so we'll make it whatever color this is, fuchsia. So the transition metals, we're going to color that color. All right. And then this box right here would also be that color. So that's what you're doing there. And you all can pick whatever color you want, just as long as they match. And it designates the correct ones. Okay. So in this case, we picked the transition metals to be this color. All right, and we'll just go in order. So I encourage you all to do this too. And I'm not going to color the whole thing with this because it would just mark it out. But basically this whole group right here, that's the transition elements. Bless you. All right. So we'll use pink for halogens. So which family are the halogens? Which number or element does it have at the top?
17.
17 or fluorine. Right, correct. Well, this one right here, the halogens, all these from fluorine to astenine, rather, not astenine. Probably if you're doing this online, a better tool will be the highlighter tool versus coloring the whole thing, even though I'll know what it is, because that way you can still see the element behind it. And again, we're going to use one of these as basically a master copy, okay, that you can use on stuff all year long. All right. The boron family is kind of easy to do. So which one is the boron family? It's the one I belong to with an M in the front. No one gets it.
What is it?
The boron family.
13.
Right. It's the one that starts with boron. So 13 gets the old Powell Valley colors, which none of y'all even know what Powell Valley is, do you? Used to be a school in this area. That's where I went to school. Back in the Stone Age. I'm so old. Moses was my class president. All right. Another easy one. We'll give it this ugly color. Oxygen family.
16.
Correct. So 16. It's the old gold color. The old yellow. Technically, we have this color in our colors, right? Yeah. We just don't ever use it.
We do. We do.
Yeah, we have.
For what?
It's like
So like a
it's
hot
like our
secondary color. Old gold, yellow gold, that gold.
We just use green.
green and one and black. The black's not even
I think the gold would look good.
I wish we could have like throwback jerseys because all those look old.
I was like green and black for like someone in the lane and like yellow or gold and white.
People get mad when we use black. Because it's not
There,
a cool color.
there's a couple like colors that can be used in anything, like gray and white, and
Somebody last year got mad because we wore black pants.
really,
Yeah, and it's not an actual color.
yeah. You're gonna make somebody mad no matter what you do. All right, so alkaline earth or red? Which one is alkaline earth? Tony?
Is it the one that starts with the name?
Right. Family 2. Okay, what about alkali earth metals?
That one is the first one.
Correct. The first one?
Is that right?
No, it's right. I was just trying to think of the color scheme here. Let's do purple. Purple, purple. Do not put hydrogen in there. By the way, since we're reviewing a little bit as we go through here, who created the first periodic table?
Dimitri and something.
Mendeleev. Okay. Dmitry Mendeleev. Sometimes. Okay. Who? What order did he put them in? He put them in order of increasing atomic mass. Okay. Is that the order that we still go by today?
No.
No. What do we use?
Uh,
Atomic number.
Increasing atomic number. And who put them in order of increasing atomic number?
Henry something?
Henry
Mosley.
Mosley. Correct. Okay. Good. All right. The nitrogen family.
The 15.
Yeah. It's the one that starts with nitrogen. Okay, so 15. What about the noble gases?
18.
18. Right.
Helium is included in that.
Yes.
You said helium. Is it included?
Yes. So it's going to be orange or orange. How about them big orange the other day? Yay. Tennessee lost. I guess Miss Serber would like me saying that, would she? All right, and the last one, the carbon family. Which one? Family number what?
14.
14. Letter G. So it's going to get this lavender, light purple color. Okay, everybody got it for those? What everything is? Yes, no, maybe so.
Yes.
Okay. It's a good thing I was running out of colors quickly. All right. So, we're going to talk about a little bit about atomic structure, okay? And how to use the periodic table to get the information that you need out of the periodic table when we're doing it. So, there was a sheet, and I thought I'd made copies of it, but I know I put it online. You all did get this sheet, right? So we'll talk. We haven't really talked about this one yet, but it is online. I will make you copies too. Okay. Okay. Did you all get this one? Did I give it to you? I thought I did. Okay. So let's look at this online. Just go ahead and open it up. Okay. So if we're talking about an atom, because an atom is the smallest piece of matter there is, and if you were to talk about it, okay, there are three things that make up atoms. And what are they? What are the three parts of an atom?
Electrons, protons, and neutrons.
Right. So you might want to take this down as notes. Three parts of an atom. Okay. They are protons. What are the other two?
Electrons and neutrons.
Neutrons and electrons. You kidding me? This thing has the worst battery of all time. Okay, so protons, neutrons, and electrons. So these are the particles that make them up. Okay. And you need to know what their location is inside of an atom. So where can you find protons?
In
Yes. These are found in the nucleus. of an atom. What about neutrons?
Alright, and the nucleus is one.
Also, yes, in the nucleus. So sometimes you will hear these two right here used together in a term called nucleons. It's not used very often, but just in case. It's just the part. If you hear nucleons used, it's just talking about the particles inside the nucleus. Okay. What about electrons? Where are those found?
The valence.
Huh?
The valence.
Valence electrons are those that are in the last shell.
So just the cloud.
Yeah, the electron cloud. Okay. And then you also need to be able to tell me what is the charge on each of these.
Electrons are negative.
Electrons are negative, that is correct. What about protons?
Positive.
Positive. And neutrons?
Neutral.
Neutral. Correct. So the way I remember the charge when I was learning this, okay, again, it may not work for you. You may have to have your own way to remember things. As long as you remember them, I don't care what you do. Okay, but the way I remembered protons, positive, because it starts with a P. Okay. Neutrons, neutral, because, or the way I remember it's neutral, nu, right? I mean, it's kind of elementary there. And then the last one, electrons, negative. The way I remembered what it was is because electricity is basically the flow of electrons. And so if you get shocked, that would probably be a negative thing. Y'all ever been shocked by like an electric fence or anything? Or ever been shocked by an outlet? How'd that feel? Feel good? I know it didn't feel good. I had a buddy in college. He grabbed a electric fence one time and he tapped me on the back of the head right here. I swear, I've never been the same ever since that moment in my life. I think he fried like I don't know how many brain cells. But anyhow, yeah. If you've ever been shocked by anything, it's pretty scary. I played with my GI Joes one time, and I decided, I used to set up these huge bad. Do y'all even have like GI Joes anymore that you play with, little army men and stuff? Yeah. Well, anyway, I set up this huge battle and made me a zip line for them, and couldn't find where to put the end of the zip line. I was just little, so I thought a great place would be that electric outlet right there. I just put the end of it there, and he could zip line down right there. Ooh, I learned real quick right there. You don't put things in an electric outlet. Not a good thing. And that was just, the small ones. It wasn't 220 or anything. So, anyhow, okay, so the key on a periodic table, it's always going to have, like the one we saw, we'll just use carbon, okay? It's going to have the symbol, it's going to have the element name, it's going to have the atomic mass, and it's going to have the atomic number. Okay, and so just to help you remember real quick. So this is atomic number. Symbol. The name. And the atomic mass. Okay. So, with that being said, all right, that right there is going to give you away a couple things. First of all, okay, what does atomic number equal?
Oh, the
Protons.
Yes, is the number of protons in an atom. And usually it's also the number
Neutron.
of electrons, not neutrons. That is if, and I'm going to put a star right here, okay? I'm going to put a star right there, and I'll highlight it. Because that's only if it's a neutral atom. What does it mean to be a neutral atom?
Not a positive, no.
Right, there's no overall charge on it. Okay? There's no overall charge on the atom. That means that it has an equal number of basically protons and electrons because protons are positive and electrons are negative. So if there's 15 protons and there's 15 electrons, what's their overall charge? Fifteen positive, 15 negative. What's the overall charge? Zero. Okay, good. All right. So, and then do the neutrons give it any kind of charge whatsoever?
No.
No. Okay. So that's atomic number. All right. So that will tell you the number of protons and the number of electrons. All right. And then we have another number here called mass number. Notice that it does not say atomic mass. Okay? Atomic mass is the average of all the isotopes of an element. Okay? So what that means is that all these elements have different isotopes. Isotopes are when it's like an atom that has the same number of protons, but they differ in numbers of neutrons. Okay? So one example would be carbon-12, which is normal carbon, okay, like what you find in graphite and all that. But then you'll have carbon-14, and what is carbon-14 used for?
Carbon dating.
Carbon dating, okay? Carbon dating is how they can tell how old, like, a tree is that they find petrified or whatever, or how old a fossil is. All right, so the mass number is the number of neutrons. Okay, so mass number is the number of neutrons plus the number of protons. Okay, so we know how to find the number of protons and electrons. We can find those from the atomic number from the element key on the periodic table. But how are we going to find the numbers of neutrons? Okay, so what we have to do to find the number of neutrons is we take the mass number I just wrote it backwards, minus the atomic number. Okay, so again, all that is, mass number is protons plus neutrons, right? And if the atomic number is the number of protons, what are we left with when we subtract the two? Right, number of neutrons. So how do we find the mass number? Is it on the periodic table?
Not necessarily.
No. Okay, not right away. It is, but not right away. What you have to do is you take the atomic mass, okay, to find this. To find mass number, what you're going to do is you're going to round atomic mass to the whole number. All right, before you leave, just put this down, okay? Round it by the atomic number by the tenths only. So if it's 0.4, it stays as that number, okay? If it's 0.5 and above, then you round it up to the next one. And a quick example, if you look at chlorine right there, y'all see it? What's the atomic mass of chlorine? 35.4527. So if you round that to the whole number and use the tenths place, it'd be 35. Okay? You don't use the 5 that's in the hundredths. Okay? You only use the 4. You don't. I know if you round the tenths to 5, then technically it goes up. But you leave it, you only use the tenths place. Okay, I want you all to study what we talked about, the families. I want you to do this sheet. Okay? Do this one for sure. All right? And make sure you put your laptops up, please. All right, people at home, I'll see you at 1:45. But that's what you all need to study too.
Okay.